This video is on chapter 50, polar curves and tangents. Now, remember what I said previously. Since x is r cosine theta and y is r sine theta, we can treat this like it's a parametric, like it's a plane curve defined by parametric equations. And so the function that we're given is r equal to 7. Now we know in polar coordinates that's just the circle centered at 0, 0 of radius 7, because r is constantly 7. And we want the equation of the tangent line at the point where theta is pi over 6. So this will be the point 7 pi over 6 is where we want the equation of the tangent line. And we'll give the equation of the line in rectangular coordinates. So x is r cosine theta. Since r is 7, that's 7 cosine theta. Y is r sine theta, and since r is 7, that's 7 sine theta. The derivative of x with respect to theta is negative 7 sine theta. The derivative of y with respect to theta is 7 cosine theta. The derivative of y with respect to x is the derivative of y with respect to theta divided by the derivative of x with respect to theta. So it's 7 cosine theta divided by negative 7 sine theta, which simplifies to negative cotangent of theta. We are given that theta is pi over 6, so we can substitute pi over 6 for theta to see what x is right here, and we can substitute pi over 6 for theta here to see what y is. So x is 7 square root of 3 divided by 2, y is 7 divided by 2. The derivative of y with respect to x is the negative cotangent of theta, so we substitute pi over 6 for theta, and the derivative of y with respect to x is negative square root of 3. Now the problem only asks us to find the slope, but we already have an x-coordinate and a y-coordinate and a slope, so we'll go ahead and give the tangent line itself. So we just have y minus the y-coordinate is equal to the slope times x minus the x-coordinate. For part B, r is equal to theta. So we graphed this in one of the previous videos, r equal to theta. And we want the equation of the tangent line when theta is equal to pi over 2. Remember, x is r cosine theta, and theta is equal to r. So r cosine theta is theta cosine theta. Y is r sine theta, and r is equal to theta. So r sine theta is theta sine theta. And when we look at it like this, again, we have parametric equations. So we do what we did before when we were finding the equation of the tangent line for a plane curve defined by parametric equations. Took the derivative of x with respect to theta, so theta is our parameter. Take the derivative of y with respect to theta. Divide the derivative of y with respect to theta by the derivative of x with respect to theta, and that gives us a derivative of y with respect to x. So this is our formula for dy dx. We're given that theta is pi over 2, so we substitute right here, cosine of pi over 2 is 0, sine of pi over 2 is 1, so y is pi over 2. The derivative of y with respect to x simplifies, plug pi over 2 in. It's not so hard because sine of pi over 2 is 1 and cosine of pi over 2 is 0. So this simplifies to negative 2 over pi. Right here is our slope. Again, the problem only asks us to find the slope, but since we have the slope and the point, we may as well find the equation of the tangent line. Since x is 0, the point 0 pi over 2 is actually the y-intercept, so we can go straight to slope-intercept form. So y is equal to the slope times x plus the y-intercept.